Yeah, hello everyone. Welcome to Kopernik's Friday night program. This evening is the total solar eclipse outlook. I'd like to welcome our in-person attendees as well as those on the live stream. So I'll wave to the camera up there. So hi to our live audience too. So before we get started with this, our final step in the march to the eclipse, at least for our Friday programs, I want to take you through just some upcoming events, both related to the eclipse and beyond. So I'm going to exit out of this slide for just a few minutes, and we're going to switch over to our website, kopernik.org, where you can learn more about upcoming events. You can find information on how to become a member here. If you're not a member already, I'll just click that. You can join online, or you can even join tonight if you want to, if you're here in person. And not only do you get into programs like this for free under Kopernik membership, but you also get to access to the Association of Science and Technology Centers, which is the ASTC. So you can click on this red link, and that'll take you to the list of all the places that you can go to under an ASTC membership, included with the Kopernik one. All right, so back up. And the front page will have some of our up-and-coming events as well as some announcements. So we are pretty much out of Eclipse classes at this point. Our last opportunity is this evening by 9 p.m. So those watching on the live stream, if you're home and need to pick up glasses, if you already have orders from online, come and get them tonight. Then this was our march to the eclipse. All of our events related to the Eclipse program fell under this banner. And all of the programs you can go back and watch, at least the ones that were presentations related to the Eclipse. So Science and Safety is there on YouTube. The Great Adirondack Eclipse, which is an amazing presentation by the president of the Adirondack Sky Center and Observatory, Seth McGowan, that's on there. Eclipse Among Spring Skies was last week. And Total Solar Eclipse Outlook is tonight, which it will post there after the program as well. Following those, our final two events are the Partial Solar Eclipse Observing Session here at Kopernik and the Total Solar Eclipse Observing live stream that we'll touch on more later about the details and where we're going to get to totality. But you'll be able to watch the Total Solar Eclipse here, and if you want to brave some crowds up here at Kopernik, you can visit us here for the partial solar eclipse. And that'll run from, both of those will run from noon to 5 p.m. For the partial observing session here at our site, the parking lot is going to be reserved for those with handicap placards. So just keep that in mind. Most likely you'll be parking on the road and down one side of Underwood. And there'll be some directions given to make sure you end up in the right place. But as cars stack up, it'll be quite a walk eventually. So do keep that in mind. Come in comfy shoes so you're ready to walk up to a mile or maybe even more, depending on how that day goes. Admission's going to be $5 per person. And yeah, well, the eclipse times are here. We can talk more about those as well, but that's where the partial eclipse event for KOSC is. And the total solar eclipse, like I said, we'll talk more about later. We also have our spring schedule out. The eclipse programs will be on here too, but you can also see the upcoming programs throughout spring. So you can pick one of these up on your way out if you want, and this will also be posted to our website soon. There's already one post for the April 12th program, our first event post-eclipse, which is on the robot seeing eye dog, which is going to be from a professor at Binghamton University. So that'll be an exciting program, I think. There's all sorts of neat STEM topics that we'll explore throughout this spring. All right, so that's a little bit about Kopernik. I will briefly show you too our Kopernik Observatory YouTube channel. This is where you can watch tonight's program, where some of you are watching now. So if I click, actually, even if I refresh the page here, you'll see we're streaming this program live. And the next one that we have on the list is our total solar eclipse live stream, live April 8th at 12 p.m. We'll talk about where we'll be streaming from. Well, there it goes. It actually, right in the title there, yep, Rice Creek Field Station is where we're traveling to. Okay, so that's how you can interact with us online. Now what I'll do is I'll switch back over to my show, and we're going to just kind of bring a lot of what we discussed over the last presentations together, and also add in some new ideas. Now that we're so close, we have at least a faint idea of some of the weather for that day, and at the very least I can give you some tools that you can use in the next day or two to get a better grasp on what will be clear and where it will be clear and where it won't be. Okay, so yeah, final solar eclipse outlook. I do say total here in the slideshow because if you're really focused on the weather and traveling around, if you're traveling that day, you're most likely going to access the total eclipse if you're braving the roads. So you may as well at that point. But here it'll be partial eclipse. Just wanted to emphasize that. It'll be a 97% partial eclipse at Kopernik. So what are we going to talk about? We'll talk about the types of eclipses. We'll just review that. If you've seen one of our past presentations, we've gone over that a little bit, but we'll just summarize that idea. Then there's solar eclipse safety, which is of paramount importance. So we're going to focus in on solar safety and observing. Then the solar eclipse at Kopernik here, and then beyond. What those eclipse events look like, how they differ. Then I want to introduce you, at least up on the screen here, to the Eclipse science team, which will be involved in the live stream up at Rice Creek Field Station on the 8th. And we'll also have a presentation with the science team on April 26th, so you can hear about their experiences from the totality. So that'll come in the coming weeks. Then we have weather forecasts. We'll take a look at a few places across the state, and just an overall look at cloud cover predicted at this time. And then we have some eclipse day checklists, just to get you in the mindset and you preparing over the next day or two, depending on where you're going to be traveling to. Okay, so let's review types of eclipses. Here are the three types of solar eclipses we're going to focus on. In fact, we won't even discuss lunar eclipses today. If you want to learn more about lunar eclipses, you can go back to our first presentation of back in early March. You can learn about lunar eclipses. But here on April 8th, we're focused on solar eclipse. And that's when the moon covers up part or all of the sun. So on the left there, you see your total solar eclipse. In the middle is an annular solar eclipse. And on the right is a partial solar eclipse. This is what you want to see, ideally. You want to see a total solar eclipse. And as we'll discuss later, total solar eclipses are, this total solar eclipse on the 8th, if you live around here, is so accessible. So it will be a little treacherous to get there perhaps with traffic, but it's just so close to us. Then we have the annular solar eclipse. The annular eclipse happened back in October of last year, and that was the Ring of Fire eclipse. If you were in, I believe, like Dallas, Texas. Actually, if you look at this map over here, at least those in the room, you can see there's that dark path going from the northwestern United States down through Texas. That is the path of the annular solar eclipse back in October. So Texas kind of it's neat, at least as long as they have clear skies both times, which they did in October, maybe not on the 8th, but there's that intersection in Texas. So if it is clear skies on the 8th, they would have gotten to see a annular eclipse, like in the middle there, and they will see a total eclipse in that section of Texas. So pretty neat. And this is when the moon is just too small. It's not able to fully cover up the sun. Now, when I say too small, of course, that's not physically too small. It's optically too small. It's all based on perspective. So when you're viewing the moon up in the sky, you can stretch your arm out and you raise up your pinky, and the moon would be about the same size as your pinky nail, roughly. And the sun is about that size too. But there's a little bit of variance as the moon goes around Earth. Sometimes it'll be closer to Earth, sometimes it'll be further away, and that changes its apparent size. So that's why we get annular solar eclipses sometimes versus total eclipses, which is when the moon is visually bigger than the sun and able to cover up the surface completely, at least during a short period of time. And then the partial solar eclipse on the right is where majority of the event, whether you're going to totality or staying here, it's all partial eclipse here, but even venturing to totality, majority of that 2.5-hour eclipse event is still partial. You only get a few minutes at most of total eclipse. So even total eclipses start and end as a partial eclipse. Okay. So those are the types of solar eclipses. I have a little video here that will take you through a total eclipse simulation. So you see the moon is passing in front of the sun. The reason it's moving is because the moon's in orbit around Earth. So this is one very neat way that you're able to track the moon's orbit, almost visually. Is if you look at it long enough, you can actually see it trace across. Now, there was that moment of totality. Very quick. Now, this is a time-lapse video, so in here it's going to be more exaggerated, but as some astronomers will tell you, sometimes it feels like that. As you're observing the event, it's like so fast. So, but you can see it starting and ending as a partial eclipse, and then hopefully it's a regular sunny day on either end. It's only that 2.5-hour period where things are going to look different. So that's a little animation of the eclipse event, if you can get to see totality. I may actually skip around in here too. As we get closer to totality, there's a couple of stages that we can also explore maybe more clearly in timeanddate.com, which is a resource I'll show you. But yeah, right in here, there are stages as you approach the total eclipse. Visually in the sky, there'll be some indications for when you will want to prepare to transition from using eclipse glasses for your partial eclipse to taking them off for the total eclipse. Again, this is only if you're traveling to totality. So these little markers here that you're seeing are called Bailey's beads. It's also known as the diamond ring effect because you can see that ring shape, basically the corona starting to appear around the sun. That's the best part about the total solar eclipse, is that white cloud is the sun's atmosphere, and it's only visible during a total eclipse. So this light here is still some direct sunlight breaking through the little peaks and valleys of the surface of the moon. And that's an indication that, okay, at least when we're starting out here moving towards totality, glasses are about to come off. And then as we move through, we get that effect again on the other side of totality, and glasses, you're going to start to put them back on, because then, ooh, there comes all that bright direct sunlight. Okay, so glasses need to stay on when you're seeing the solar surface. So here you'll have the glasses on the entire time if you're staring at the sun. Okay, which is a good transition to getting more specific and talking about solar eclipse safety. So eclipse glasses. These are your best friend during the solar eclipse, whether you're venturing to totality or not. I'll show you a pair here. A couple pairs I'll go through. So this is what eclipse glasses look like. There are safe ones that you can seek out. I'm not sure what our store stock looks like at this point, but we may still have some out there. You're looking for ISO certification with these glasses and that they're sourced from a reputable vendor. So the way you use these eclipse glasses is you face this is our sun model up here. We'll use that as our sun that we're going to observe. So as long as you're looking away from the sun, you don't need eclipse glasses. And of course, on a regular sunny day, you may catch reflections of the sun. You may just catch glances of the sun as you're outside. That's fine. That's going to happen. Our eyes evolved with the sun in the sky. That's not going to hurt us. What does hurt you is staring at the sun. That you're not supposed to do. So again, if you're just looking off to the side, you're not staring at the eclipse, you don't need glasses on. But as soon as you decide, I want to look at what the eclipse looks like or what the sun looks like, and you're ready to start staring at it, you got to put the glasses over your eyes. And glasses wearers, try and fit them over your glasses. And you turn around, and you can observe the sun for as long as you want. Glasses that were made with the newest ISO standard, and as long as they're sourced properly, these filters can work indefinitely. So as long as they're not scratched, there's no hole punctures in them, they are safe for your eyes. So keep that in mind. But I can stare at the sun, for as long as I want. You won't be seeing anything else though. So if you're around a lot of people, as soon as you're done staring at the sun, you can take them off so you can see. Something you don't do with your glasses. This is a pair that we used as a model. We made a few of these as demonstration pieces. So I'm not even sure where the real one is anymore. But the idea with this is that someone in 2017, when they were viewing the partial eclipse up here, put their eclipse glasses on, and then they took a pair of binoculars. Maybe. There we go. And they held them up to the glasses and looked through the binoculars at the sun. And what that did is it melted two holes, one in each filter. And you can see them up on the projector there. I'll come around and show you too. A hole in each lens. So that happened instantaneously. And that's what would happen to your eyes, which would cause permanent blindness, partial or otherwise, but still permanent damage to your retina, and you don't want that. So no binoculars, no telescopes paired with your eclipse glasses. These are just for your eyes. I will give you one exception, keeping in mind though that you have to protect your eyes even if you're trying to capture an image. So if you use your camera on your phone, you can capture an image of the solar eclipse. In fact, you really don't even want to take an image without a filter of some kind on, because it'll be way overexposed anyway, at least if you're taking it through a default camera app. So what you can do, and this works really well if you have a second pair, so maybe borrow someone's, borrow friends or family members, and you can place it over the lens of your camera, and you can capture an image of the eclipse just like that. Another way to do it is even safer, because this will mean that your back is to the sun. You can put it over your selfie camera. It won't be as nice of an image. You'll always get better images out of your rear-facing cameras, but that's an option too. So there are some ways that you can capture the eclipse, but do keep in mind that there'll be so many images to explore online after the fact from some really amazing astronomers out there. So enjoy the event with your eyes as much as you can. So let's see, grab there's my remote. In addition to protecting your eyes, it's still sunny, well, hopefully it's still sunny out during a solar eclipse. So as long as there's direct sunlight shining on you, even if it's most of the sun's covered up, it can still cause sunburn, and you'll be out in the sun a long time that day, potentially. So wear sunscreen as well. The light that damages your eyes, ultraviolet, is the same type of light that will damage your skin and cause sunburn. So make sure you wear sunscreen that day too. You can also have some fun with partial solar eclipses. There'll be a lot of time for that because, like I said, majority of the eclipse event is partial if you're going to seek out even totality. So pinhole viewers and pinhole projectors can be a lot of fun. And the basic idea is you just punch a hole in something. You can punch a hole in a piece of paper. You can take a Ritz cracker. You can take a strainer, a spoon with holes in it, anything. Like anything with small holes like that. And you can project an image of the eclipse on the ground. We don't have much in the way of tree leaves at this point in the spring, but that's an example of, like back in August of 2017, that was something we could see very clearly. Where the sunlight traveling in between the leaves of trees, you'd get these little crescents on the ground, where usually they'd be more circular in shape. But that's pinhole optics in action. So you can try this yourself. Another easy one is just to take your fingers and cross them, and the light that shines through, the sunlight, will project little eclipses on the ground. So that's some fun to be had with partial eclipses. All right. So the eclipse at Kopernik and beyond. Let's have a look. This is actually very similar to the map that's up I pointed to on the wall there for the annular solar eclipse. You'll actually see they do map out the path of totality for April 8th as well, as I mentioned that intersection. But now we're just going to focus on April 8th. So it's a map of the US primarily, showing you this dark path which maps out the path of totality. And when you get this map up on your own screen, you can very, very clearly see these gray lines mapping out the partial eclipses. So if you follow one of these gray lines up along the path of totality, you'll see this little number here says 95%. So that means 95% partial eclipse in that region. The dark path, though, represents the 100% total solar eclipse. All right, so it starts down here in Mexico, and it travels through the states. This is the eclipse, I should mention the total eclipse over time. So at any given instant, my little red dot on the screen there is too small, a little bit too small, but it gets the idea of cross, that the shadow of the moon is moving through this path, roughly circular in nature, and that's the darkest part of the shadow. You'll also see some a fuzzier part of the shadow. If you're looking down on the eclipse from space, you'd see a fuzzier shadow, which is the penumbra, and that's what causes the partial solar eclipses. But this is going to be a dark circular shadow moving up. And here we are in northern New York State. Binghamton is down here. So we're not quite in the path of totality. We are past the 95% line. So we do get 97% partial solar eclipse in Binghamton area. And you just have to travel north to get into the path of totality. North of Ithaca, you can go to Syracuse. Those are some close by options. They're not quite center line though. So if you are right here, if you get like into South Syracuse right at the edge of the shadow, totality will only last maybe just a few seconds. So that's not a lot of time, and you don't have to do much driving to get even 2 minutes. So like North Syracuse near the mall up there, those are going to give you 2 minutes of totality. And then you can go into Rochester and get like 3.5 minutes of totality. So the closer to the center of that shadow you get, the more time of total eclipse you have. Okay. So here's everything zoomed in. We're going to watch this video from where the eclipse starts. So you can see it starts out in the Pacific Ocean, and then it's going to start traveling across Mexico. So this is that the shadow at the given time up in the upper left on April 8th. This time is going to change based on where the shadow is in the time zone. So when we get to our Eastern time zone, you'll see it shift to EDT. I do like the visual of showing the city lights coming on as the path of totality travels through. So going through Texas now. We'll pause it once we get to our region so you can see some of the cities. Moving through Missouri, and Illinois, Indiana. Getting close. We're heading into Ohio now. Sure, there'll be some boats out on the lakes.
Oh, yeah.
All right, so here it just entered New York, and we're basically that's dead center for Buffalo there. So Buffalo's going to be a crowded place for sure, assuming skies hold up. Hmm?
The forecast I saw this morning between 500,000 and 750,000 people in Western New York.
Whew, wow. That's incredible. So yeah, things are going to be busy that day. We'll talk more about some checklists for that. But then we head to Rochester, not too far off from center. And again, the difference is around the center is pretty negligible. It's like maybe 10, 20 seconds extra totality closer to center. Going into Oswego, the Eclipse science team at Rice Creek Field Station is going to be up in here, just like probably closer to here in South Oswego. So there, I think we have just under 3 minutes, 30 seconds of totality. Then we head into Watertown. They're pretty center. Then we have the Adirondacks right here. This is where Tupper Lake is, and that's what the presentation I mentioned earlier about the Adirondack Sky Center. They talked all about their event they have planned in the Adirondacks at Tupper Lake. It was a brilliant presentation, so it's definitely worth going back and watching and learning about all the activities and events they're doing that day. Okay, carrying on into Vermont and Canada and Maine. And notice too how the shadow is changing as you get to this point. We'll watch it through here. Because keep in mind, we're not looking at a flat surface, right? We're looking at a globe, but projected onto a flat map. So, and eventually the moon's shadow does have to move off from Earth's surface. So that's effectively what you're seeing there as it heads out into some of the Atlantic there. Okay, so that's an overview of that path of totality. Those videos that map and that video, they both came from NASA. They're free online. You can download them yourself. So if you go to NASA Visualization Studio and search for solar eclipse, that's where you can get those. It's a really nice graphic they came up with. Okay, another option for searching for detailed eclipse times is timeanddate.com. So we're going to jump to that. So we're going to search. You can just do timeanddate.com solar eclipse. If you just search for that, you'll come. The first result is what you want to click on. And if we search for Vestal, New York. We're going to look at Vestal first. We'll even do South Vestal because that's where we are. And come down here and click April 8th eclipse. So it gives you a summary. We're going to even scroll down a little bit more to get a nice overview, and you can also play through the eclipse event. It pauses at each major event, like when partial eclipse starts at 2:08 p.m. for us here, and then getting to maximum eclipse at 3:23 p.m., and then around 4:35 p.m. you get the partial eclipse ending. You can even do a detailed view, which breaks it down into sections, and some effects you might see, because even at 97% partial eclipse, you're going to be noticing some interesting light effects, certainly some rough dimming to the sky. So this one example of that here is, in this range, you can see not even much of the sun is covered up yet. That gives you that at this time around 2:45. And it says sharp and blurry shadows. So if you look around the room at all the shadows, or at home if you look at shadows in your space, you'll see they're very fuzzy. And the reason they're fuzzy is because there's a lot of light sources in the room and in the space. And even on an individual level, you see like the fluorescent lights in the ceiling. They're long, there's a lot of light coming from them, and they're diffused. And that's good for lighting up a room like this. But the effect that has is causing blurry shadows because there's light coming from all sorts of angles. But when you're dealing with point source light, you get very sharp shadows from that because light is effectively only coming from one angle. And that's what starts to happen as you go deeper and deeper into a partial solar eclipse. You're losing more and more of that orb of sunlight in the sky and reducing it down to an approximate point source of light. And the result of that is getting very sharp shadows on the ground cast from the remaining sunlight in the sky. So that's a neat effect. I do remember seeing that back in both 2017 and there was a early morning solar eclipse back in 2021 in June of that year. So that's a really neat effect. So here even, maybe around 50% or so, you're going to start noticing some brightness changes in the sky itself. You can even look for, it says light levels and colors changing as you lose more and more of that direct sunlight. And even around here, you may see reactions from biology around us, the life around us. So you can pay attention to how birds and if we have insects out that day, listen for those, see what happens. So that's a nice detailed view and breakdown, and it even better for totality too. So if we go up to, let's just go to Rochester. So here's a place with totality and a rough breakdown. The timeline is going to be pretty similar. You see it's like really only a minute or two off for major eclipse events. So 2:07 p.m. in Rochester, and then totality begins at 3:20, maximum at 3:21, totality ends at 3:23, and eclipse ends at 4:33. So not too far off from our timeline here, but of course what's different are some of the events leading up to it. So here's a huge section that we just won't have at all, where you start to see the corona appear and the diamond ring effect with Bailey's beads. So you can see just how much there is to observe, even in just that short window of totality compared to a partial eclipse. So this is just an incredible resource for you if you have a specific place in mind or just want to bop around to different places. Okay, so that's time and date. My next slide was about the eclipse in stellarium. This is just, I'll mention very briefly because I talk about stellarium so much. you can get Stellarium at stellarium.org. Whoop. It's not happy with Stellarium. There we go. It doesn't want me to show it. Yeah, stellarium.org. It's free. There's a web version. You can download it for just about any device, and it's really not happy. Maybe I'll just exit out. The basic idea is it's your at-home planetarium. So you can explore the skies with it. But if it's, for whatever reason, not pleased with that, it really was Stellarium. Okay. That's fine. So we'll just skip that for now. All of our other presentations touched on Stellarium. It's a great resource. All right. So now from here, I want to talk about Kopernik Observatory's Eclipse science team. This is operating under and funded by many organizations. So the two that we're operating within is DEB, which stands for the Dynamic Eclipse Broadcast, and Einstein's Incredible Universe. So DEB is responsible for the actual citizen science project we're working on. And they organized it, SIU, that's Southern Illinois University, Carbondale. They're the astronomers and researchers that put that citizen science project together. And the goal of that project is to get science quality data using some using modern tools in astronomy, but fairly modest telescope and camera equipment. Like our gear costs, I believe it's maybe around $1,500 if you were to go just outright and buy it somewhere. So fairly modest price to get research quality data. And that's the goal, because they sent all these kits to over 70 organizations across the country. I'll show you that map and where all the observing sites are. But yeah, really neat project that they put together. And Einstein's Incredible Universe is the direct program we're operating under. And their goal was to take DEB and bring it to students, especially women, to get them engaged in STEM across a variety of experience levels. There are groups in Einstein's Incredible Universe from Girl Scout troops, middle school students, high school students. Ours is a college group of students from SUNY Broome. So yeah, there's really diverse groups between Einstein Incredible Universe and DEB. If you're wondering where the name comes from, that's actually the name for the full dome show that they're putting together under a similar purpose. It's going to be a kind of a biopic show about Einstein himself and his experiences and how he inspired generations and still continues to this day. So that's under Cosmic Picture. You see there's all sorts of things like interweaving here, and it's pretty amazing, the people I've gotten to meet through this project. But that's also through the National Girls Collaborative Project. So these are partners, everyone's partnering, and money and grant money from National Science Foundation played a role too. So very neat, but let's talk about our team now. Actually, yeah, we could watch this. Let's do this first.
Dynamic Eclipse Broadcast Initiative, which we also call
It's
the
pretty
DEV
quiet.
Initiative, is an
And now I don't have any volume. Oop. Hang on.
broadcast initiative, which we also call the DEV Initiative.
And nope, doesn't like this video either. It's just dropping out on us. I'll continue on the current plan of skipping it. So we'll skip that. We'll come back to that video and an introduction to DEB again for the April 26th event that goes into detail about DEB, Einstein's Incredible Universe, and the Eclipse science team and their experiences during the eclipse and all the imagery we got to. So you'll see all that later. I do want to introduce you to the team. So the left-hand image was a picture taken when we were observing some sunspots on the sun using our heliostat. The heliostat will be open on April 8th for solar observing. It's a projection telescope. really nice piece of equipment we have in the physics lab. So the science team, we took a picture around this. There's me, Sasha. So we're the two leaders of the Eclipse science team. Sasha is also a SUNY Broome student and helped put the team together. So here we have Elle, John, and Tyler. And here they are hard at work with their rig. This is the telescope and camera system that's going to be responsible for capturing that science quality data. Like I said, fairly modest rig. You don't need a lot to capture the coronal data that they want, as well as photosphere, which is the surface of the sun. And they're working on the laptop over here to collect their imagery and data. So really, the nice part about the gear too is we can easily transport it as well, along with all of our other rigs that we're taking up to our observing site. So here is the map for Dynamic Eclipse Broadcast and all the organizations that are involved, both from EIU and from DEB itself. So with EIU, that's Einstein's Incredible Universe, there's like, I think, 20 organizations now, and then everyone else is just from DEB itself. So these are Eclipse imaging sites. So all the blue markers are Eclipse imaging. There's also Eclipse live video sites that have access to stable internet. We'll be doing our own live stream outside of this, so we won't be live streaming for DEB, but we will be live streaming for Kopernik. And you can see the path of totality there, and you can also see there's lots of observers not within the path of totality that will just be capturing photosphere data at the time of the eclipse event, the total eclipse event here. So it's really valuable because you're capturing all sorts of data throughout the duration of the eclipse event across Central and North America. And it's basically to bank a whole bunch of data on a prospective basis for scientists and astronomers to use in the future. Okay, now we'll get into some weather forecasting. I am not a meteorologist, so I'm going to give you a resource that you can use leading up to this. It's still a bit early for cloud cover to have like a firm handle on what Monday looks like, but I think we're just getting to the point now where we can actually get some use out of it. So let's go to astrospheric.com. This is a great astronomical website that you can look at pretty much specifically for cloud cover, transparency, and seeing. It's similar actually to our clear sky chart that you'll find at the bottom of our webpage in this breakdown here. So you could use this as well. But this, of course, isn't giving you the map data that Astrospheric does. So that's kind of a nice visual to work within too. So this is the skies as they are right now at our current location. And you could just hit play and watch the cloud cover play out over time. But what we'll do is we'll just skip around a little bit and see if we go out to Monday, at least the current projection, that's 3 p.m. And you can see it just around that maximum eclipse time. At least the current forecast model is predicting some clouds there. So the darker the blue, the better. So you're talking about the difference here. It says 73% cloud cover at 3 p.m. If you back it up, it says 38%. Back it up to 1 p.m., 20%. So this is when the eclipse starts. This is 3:23 is maximum, and 4 p.m. is when it starts to end. So as of right now, as you go through, maybe it clouds up more. It's not solid by any means right now. We'll see more. I think really Sunday will give us a better idea of what it looks like across the region, but that's where we're at. And because we can see the map above, you're also able to notice how when we click through, it's definitely like partly cloudy conditions, what it's showing here, that get cloudier as time goes on. If we click on the map, you can zoom around and set a new location. So if we went to, let's go to North Syracuse, right up in here. And we'll say get new forecast. Now we've switched our region so that we can see the cloud cover there. Again, it's pretty similar for things around after 2 p.m. Get a little cloudier, but even around 4, it looks like Syracuse would be saying 40%. So, yeah, maybe. I think at this point, like, there'll be some form of clouds that day, most likely, some kind of partly cloudy skies. But that's better than overcast like we had on October 14th with the last eclipse. So it was completely cloudy skies here, but then one of our educators, Sasha, who's on the team as well, she was down in Texas, and it was beautiful blue skies there. So this week it was kind of starting to look like it was the opposite. We were going to have super clear skies here, and down in Texas area they would be cloudy. But now things have started to look like they're clouding here. We'll see. Again, there's time for it to change, and even still, partly cloudy is good. I will happily take partly cloudy. If we go to our observing site in Oswego for the science team up in here, that'll be pretty similar. Again, looks like it's closer to Syracuse, but oh yeah, there's some windows there. So there's our maximum eclipse timeline, and I don't know, that just seems like suspicious to me. It's like suddenly it gets cloudy at totality. Yeah. But the other thing to note there is that because totality and solar eclipses in general bring the temperature down a couple degrees, there can be some unexpected weather effects from that, and sometimes the net effect is less clouds, and if you're in a place that has predicted rain that day, it can even cause effects of precipitation. So it's there's really hard to predict what the eclipse will actually do to the skies itself with those temperature changes. That was actually something, another thing that Seth McGowan brought up during his presentation, and had a nice visual of like, oh, it was cloudy, but just before totality, and then boom, suddenly clouds started to clear a little bit, and they got to see the corona and the total solar eclipse. I can't remember where he said that was, but it was a pretty nice visual, and made me optimistic. So keep optimistic with this is my suggestion. But use astrospheric moving into the next couple of days, and keep listening to meteorologists and what they have to say for Monday. I remain hopeful. And if you really, really want to brave things, you could even plan to drive to, on the day of, like change your plans, go visit another state park near totality, and maybe you'll have better luck elsewhere. I think for us, we're just committed to Rice Creek Field Station, and we're just going to see what happens. Okay. All right, so Eclipse Day checklist as we start to wind down the show, and this is kind of where we're leaving you for the eclipse event. So if you're staying home, like literally, if you're staying at your house, you have a good enough view of the skies there, you're okay with a good observing a partial solar eclipse and seeing that 97% maximum, that's all you need. Just eclipse glasses. You can just step outside when you're ready to observe the sun. Glasses go on. Observe it as long as you want with your glasses over your eyes. So you can just stay at the comfort of your own home for that. You would miss out, I guess, on things like if you went somewhere that has access to telescopes for safe solar observing. But if you're just interested in seeing the eclipse at a given time, you'll definitely see the shape of the partial solar eclipse in the sky. You can play around with pinhole viewers at home, and you can, of course, even try and take some pictures of the partial eclipse with the filter in front.
So the sun
Yes, yep. It'll be westward, but it will also be early enough that it'll be high in the sky. So yeah, make sure you have a decent clearing in the western sky, but it'll still be pretty high up there. Mhm.
I was confused because usually the moon at my house comes over from like the east.
It all depends on what time.
I'm
Yeah,
like, how did they even meet up?
yeah. It all depends on what time as the moon orbits around the Earth. But yeah, so if you're traveling nearby, like if you live around the area and you go to a park, a lot of libraries are having events, colleges, Kopernik. So if you're traveling nearby, you want to make sure you pack your eclipse glasses, bring your own food and water wherever you go, bring some folding chairs, and expect crowds at major locations. We're expecting big crowds there up here that day, so yeah, make sure you just come prepared to be around people, and just come to be as comfortable as you can.
Kopernik planning, projecting 800 plus, or
What's that? Sorry?
are they projecting as big a crowd as Halley's
Oh.
Comet?
Oh, yeah. So, what's the number we have for the 2017 eclipse that we?
1,500.
Okay, so yeah, back in 2017, we had 1,500 people up here during that partial solar eclipse. That was 70 or 80%, if I recall. This is a 97% partial, but also totality is closer. Either way, there's going to be a large influx of people moving this way through the states into this region. So that will have a net effect on who we see here at the observatory. And yeah, it's hard to say, especially now that a lot of schools have called early dismissal. Some schools have closed. Yeah, it's kind of unpredictable at this point where we'll be at. But because things are even looking modestly decent that day in the sky, we'll expect to be pretty crowded. So if you're traveling to totality, this is where you really gotta put some things in mind and into perspective here. And this is not comprehensive. I by no means am here to prepare you perfectly for the day of the eclipse. So I'm just giving you the best idea of what traveling will look like if your plan is to go there and come back. If you already have a hotel reservation, you're going there this weekend, great. Just stick around for as long as you can before and after based on your reservation. But this is if you're traveling the day of. So eclipse glasses, always. Be prepared to be on the road. So anything you might need on longer road trips. If you're just traveling to Syracuse, that's usually an hour and a half drive from here or so. Make sure that you're preparing for like 4-hour travel time, maybe both there and back. It's hard to say what the roads will be like. Then full tank of gas, or if you drive an electric vehicle, charge up your battery all the way. It's with all the cars on the road, gas stations and charging stations are going to be overwhelmed alike. So there may even be fuel shortages in some cases. Then, yeah.
There's a sign up in Whiteman's that they're going to be closed during the eclipse.
Oh, yeah. I know some companies have decided to close down so that employees can enjoy the event. So, yeah, keep that in mind, too, that there might, especially closer to the major points of the eclipse. I mean, you'll be wanting to, at that moment, watch the eclipse anyhow, but there may be some locations that will not be providing service that day or during specific times. Then food and water, again, pack lots of that. Be over-prepared is a good thing. Prepare for traffic. That ties in with be prepared on the road. Yeah, just you may be sitting in traffic for quite a while that day, especially along major highways, even along back roads. It's during the high points that day, like the rush that comes after the partial eclipse, for example, for people to just get on the road, that's going to get backed up. Just, yeah, be prepared to be sitting in your car. Don't rush. Take your time. The New York State Department of Transportation, you may have seen all those signs across our state right now, all flashing to arrive early and stay late on April 8th. That is a good recommendation. Do follow that if you can. If you're somewhere that you can stick around post-eclipse or get there early, that is your best bet for safety. And then cell phone service with all the crowds around. That will get congested. So bring power banks, even if the service is not working. You know, at some point, hopefully it would come back online and you'd be usable again. But yeah, that's going to be another concern. So it's all worth it, I think. You know, it's especially to traveling to totality with it so close. But yeah, you just set your expectations correctly for travel that day. And in the end, it's only a day, right? It's 24 hours, hopefully. And then you've gotten to see a total solar eclipse that was so close by. And the next one, you don't have to pay to vacation to it. So all the better. So any questions at this point? This is kind of our last Q&A session before April 8th. So if anyone has any questions from here at Kopernik or on the live stream, I'm happy to answer those now. Any questions here? Yes.
I have a dog, and we're usually walking
Mm-hmm.
sometime in the afternoon. So, I mean, obviously, you can't put their glasses on and walk.
Yeah.
So what's your?
Sure. So the question for those on the live stream, if they weren't able to hear it, was about pets and how we should prepare them for the eclipse. The nice thing is that during the eclipse event, things aren't getting more dangerous. The light isn't getting more dangerous. It's just becoming more interesting. So for us, we find eclipses, I mean, if you look throughout history, we've always found eclipses incredibly enticing, and it just sparks curiosity. So the inclination for humans is to look at it. And we, places like Kopernik and all the messaging that has gone around about eclipse glasses are there because we want to protect your eyes when you are curious about it, as you should be. So we don't want to stare at a regular sunny day, stare at the sun on a regular day, and we don't want to stare at an eclipse, all for the same reasons. So animals, though, like pets, they aren't likely to just look up and stare at the sun on the day of the eclipse. They'll just be operating more like, wait, it's getting maybe a little bit dark. Is it nighttime? That's where their curiosity lies, and that's how their behavior will change throughout the eclipse event. So there's no real risk to your pets during the eclipse, beyond just how their behavior changes. Mm-hmm.
You'll expect supper early.
Yeah, there you go. Yes. Yep. All right. Great question. Any other questions?
We have a couple here on the chat.
Okay.
MH asks, what other equipment will you be bringing to Oswego?
Oh, all sorts of stuff. Great question. As far as the DEB equipment goes, that is a telescope, a mount for tracking, a camera, and a laptop. That's pretty much it. It's to record their data. And that will all be its own independent rig so that we can keep it separate from the live stream component of that day. For the live stream telescope, we'll be bringing C-Star S50, which has just been a brilliant solar scope for us here at Kopernik, and among other things. So C-Star S50 is coming with us to operate the live stream. And we'll also have a camera for on-the-ground happenings, so like what the science team is doing, anyone that wants to come chat with us. And there are some other citizen science projects going on up there too, which will be really neat. Maybe we'll talk about those. And then there are a couple other rigs too. Sasha is bringing her own personal rig to image the solar eclipse and the total eclipse. I'm bringing my own. So yeah, we'll have all sorts of equipment up there. And we can get into more details and show you on the stream what that looks like.
You want to tell them how you're going to get on the internet?
No.
Okay,
Yeah.
we'll do that. We'll be fine. Also, MH has a couple other questions. Any thoughts on today's earthquake and any connections to the eclipse?
That's an interesting question. I got that message on my phone today about the earthquake. I didn't feel it. The phone's vibration was stronger than any earthquake that out there for me to feel, at least in my location. I don't think there's any inherent connection. The geology of the Earth is outside of the scope of what's going on with the eclipse, and the eclipse in the sky, it's literally just the moon passing in front of the sun. There's currently no effects. It's just, as far as the moon's concerned, it's just going around Earth, and as far as the sun is concerned, it's just there. And then eventually they cross paths, and just like if you cover up a light in the room, that's all it is. So no net effects here on Earth beforehand or after. During the eclipse, yes, there will be some weather effects because you're getting temperature changes. There will be some biological effects because animals are going to be reacting to the sudden drop in daylight. But that's about it. So yeah, thanks.
And then finally, what planets or other objects we might see during totality?
I was going to show maybe that in Stellarium, but now I don't know if I dare go back and try it. Maybe if I try the downloadable version. Let's see if it likes that better. So far, so good. Here's Stellarium. This is the one you can download for your computer. And I can travel to... Oh, no, that's May. Let's go travel day by day to April 8th. But this is April 8th at our current time, around 9 p.m. So let's back up to around when the eclipse starts that day, just around 2 p.m. And if you pan the camera up, you'll see the sun in the sky, in the southwestern sky. And you can click and zoom in to see what's going on. Now it looks like the eclipse event has started, but if you zoom in more, you'll see that the moon's not quite passing in front of the sun yet. So if we travel through the minutes, right around just after 2:08 p.m., that's when the moon starts first crossing the sun. And there's this little bite out of it down here. Okay, we can keep traveling and get to our maximum eclipse. Stellarium is doing its best here to simulate sky effects and how things appear to dim. And we'll go to 3:23 p.m. for our maximum, just that tiny little sliver. And again, that is not safe to look at with your eyes. So make sure you have your glasses on throughout the duration of the eclipse when you're looking at the sun. That is enough sunlight to cause damage to your eye. All right, and then we'll carry on to 4:34 p.m. when the eclipse wraps up. And there we go. So that's the eclipse end. So that's how you can simulate. But I want to show you a place with totality. So we'll jump to a different location here. We'll go to Oswego if it's in here. Yep. Zoom out. And we'll back up the clock again. Because we want to see total eclipse. Again, this is Oswego, New York. There we go. So it simulates the solar corona there. And zooming out, you will see that in the darkened skies, one of the descriptions I've heard for it, I've never seen a total solar eclipse myself. One of the describers for it, the brightness of the sky is similar to a full moon at night. You can also think about it maybe as the twilight, just before sunrise and just after sunset. It's in that range maybe. And this is showing you that the brighter planets, Jupiter, Venus, and Saturn will be out. Mars maybe less likely, especially because Saturn and Mars are hugging the horizon a bit, and Mars is going to be much dimmer than Saturn. I couldn't guarantee that, but maybe Saturn and Venus and Jupiter are going to be pretty bright, so those should be visible. Mercury is out here too, but Mercury is, see, I don't know, where is it? It's over here. If we target Mercury, there. You'll see it's this hyper thin little crescent. It's almost a new Mercury. And that's not going to be putting off enough light really to notice it in the sky. But it is there, and it is kind of cool to know it's there. Also, you may have noticed that there is this popping out over here, 12P Pons Brooks, which is a comet. This comet has not brightened up quite enough, nor has it flared. I mean, that'd be would have been the hope, is that it flared up as it got closer to the sun, and getting ideally even to a brightness closer to the planets here, which would have made it visible to the naked eye during the total solar eclipse, which would have been quite the sight. Unfortunately, that's probably not going to pan out that way, but arguably, yeah, some long exposures taken during the eclipse event should be able to pick up its presence there during the total eclipse, which would be neat. That comet is just about visible to the eye as it sets. After sunset, you'll see the comet in the sky right now at nighttime. But with totality, the skies are going to be bright enough that you won't really probably be able to see that there. But yeah, we'll see what becomes of that comet during the eclipse event. Anything else? Some brighter stars in the sky, like maybe Sirius, that's out. So yeah, those are things to look for out of just general curiosity, like, oh, it's getting darker. But if you have the eclipse to observe, enjoy the total solar eclipse, because all these objects we're talking about, even the comet, is visible in the night sky at some point during the year. So solar eclipse, a total solar eclipse isn't, and they can be pretty challenging to access for most people. So take advantage of totality and save planets for later. All right, any other questions from the stream?
No, that's it at this point.
Okay. Any other questions from our live audience here? Okay. Then, yeah, I hope you all have an excellent eclipse. Thank you so much for joining me at Kopernik Observatory today. And yeah, Monday's fast approaching. I hope you have a wonderful time.